In this video for section 6.1, we're going to talk about how to calculate expected value of a random variable. A random variable is based on the outcome of a random event. So something like taking a survey or doing an experiment, a random variable is the possible results of that. And there are two types, discrete and continuous. Something is a discrete random variable if the results can be counted. Generally, for a discrete random variable, that means that only whole numbers are possible. For a continuous random variable, that is anything that can be measured, like height or weight. So decimal values are possible as long as you can measure something that precisely. So for these first examples, we want to state whether the variable is discrete or continuous and list the possible values that this random variable may take on. So the first one is the speed of a car on a LA freeway during rush hour traffic. So speed is something that we measure in miles per hour, generally if it's a car, and so that means that it is continuous. And possible values, well, it could be any positive number. It can't be a negative number, but any positive number, or it could be zero, because during rush hour, it's possible that your car isn't moving for a while. So I would say any number greater than or equal to 0. Number 2 is the number of phone calls to the attendance hotline of a high school on any given day. Now, number of phone calls is something that cannot be a decimal. It has to be a whole number. It wouldn't make sense to have half of a phone call. So this is discrete. And possible values it could take on, well, they could not receive any phone calls, so 0 is a possibility, or it could be 1, or it could be 2. There is some sort of upper limit, but I'm not sure what it is, so I'll use n. Number 3 is similar, number of goals scored in a soccer game. You can't have half a goal. It has to be a whole number, so this is discrete. And the possible values, again, you could have 0 goals scored in a game. Maybe it just ends in a tie. It could be 1 goal. It could be 2 goals. Any number of goals. And number 4 is the heights of players on a basketball team. Height means that it's measured, which means that it is continuous. Decimal numbers are allowed. And for this one, I would say 0 is not a possibility, because if you don't have any height, then how are you a person playing on a basketball team? So I would say any number greater than 0, but 0 is not allowed. There probably is a lower limit to how tall somebody can be playing on a basketball team, but I can't really say for sure what that is. So we'll just say any number greater than 0. So we're going to focus on discrete random variables here. And what we're going to do is make something called a probability model, where we list the possible values and the probability of each occurring. And we have an example of a probability model right here. It shows number of cars per household. So we have 0, 1, 2, and 3. You can't have a decimal number of cars, can't have half a car. And the probability of each occurring. So this is based on probably survey data, where they asked people how many cars they had in their household, and then they calculated the probability using the number of people who gave each response divided by the total of number of people that responded. So what we're going to calculate is first is the mean of the discrete random variable, and we use this symbol. This is called mu to represent the mean, and it's also called the expected value, because we can use it to answer the question, how many do we expect? So think of this as a different way of calculating the mean than we talked about earlier. Earlier we calculated the mean by adding up all of the data values and dividing by how many we have. This is an alternative where we use the probability instead. And to calculate the mean or the expected value this way, this is the formula version. This is the Greek letter sigma, the big kind of E thing. That stands for sum. And what we're doing is we're multiplying each possible value by its probability, and then we're adding all of those together. So this is it written out in words, sort of as the instructions for that. So it gives us what we would expect to happen in the long run. And we can't do this on Minitab. We're going to talk later about doing some other types of calculations on Minitab. But for this, we have to calculate it by hand. So what I'm going to do here is multiply each data value by its probability. So we have 0 times 0.142. Obviously that's going to equal 0. 1 times 0.378 is 0.378. 2 times 0.423, so I'm just multiplying kind of across the table each x value by its probability, and that's 0.846, and 3 times 0.057, and that would equal 0.171. Then I add all those values together. So you can do this on a calculator or just adding. I get 1.395. So what this tells me is that the average number of cars per household is approximately 1.4. Now obviously no household is going to have 1.4 cars. Can't have a decimal number of cars, you have to have a whole number. But on average, if I took a bunch of households, added up how many cars they have, and divided by how many households I used, then I would find an average of about 1.4. Our second example, this is a day trader buying an option on a stock. It will return $100 if the stock goes up today and lose $400 if it goes down. If the trader thinks there is a 75% chance that the stock will go up, what is her expected value of the option's profit? So it seems like probability of 75%, that's a pretty good chance that it's going to go up, so it seems like that's a good buy. But let's calculate the expected value and see. So we don't have a table for this one, so we're going to have to make our own, where we list the possible values and the probability of each. So one possible value is that I could gain $100, and the probability of that happening is 75%, or 0.75. The other possibility is that I lose $400, and for these problems, when you're talking about money, gaining and losing money, if you're losing money, then you want to make the x negative. So this is a case where you could have a negative value for your random variable. So if I lose $400, the probability of that happening would be 25%, because that's the only other option. So now I'm going to multiply each value by its probability. So 100 times 0.75 is 75, and negative 400 times 0.25, that's negative 100. So if I add those together, I get negative $25. Now, since the expected value is negative, that tells me that the expectation is going to be that I lose money. Now notice that negative $25 is not a possible thing that can happen in this scenario. The only possibilities are that I gain 100 or that I lose 400. But if I were to repeat this many times, over time, on average, I would end up losing $25 overall. And so what this tells me is that this is not a good idea.